Hey kiddos, let's start by taking a look at this flowchart that you got on Thursday or Friday. This is a list. This is a thought process behind all of your different integration techniques. You don't know all of them yet, so some of this doesn't make sense, and that's okay. But to start off, if you can graph your integrand and just find area under and you have a bounded region, great, do it. So we've already got that one. Is this the back of a flashcard? Now, sometimes this one's tricky because you've got to make sure you have all your derivatives memorized so that you recognize them when you see them. So yeah, I can check this off because we've already done it, but sometimes those are sneakier than you think. U sub is what we've been focusing on this week. You're looking for something in your function whose derivative is in the numerator of your function so that you can make that something your u, and then your du is incorporated in there. This whole yikes, we might be doing it by parts, that's coming later. Don't worry about it. But here's a whole other section of options. If you're looking at a rational function, so some kind of division, a polynomial division situation, this is the one we're going to do today. If we have an improper rational function, meaning your numerator is greater than your denominator, so your degree on top is bigger than your degree on bottom. All right, so this is where we are starting today. Always be on the lookout. That doesn't apply to you yet. So an improper integral is different than an improper integrand, I guess, and that it's different than an improper integral. Those are coming later. Okay, so let me show you an example. Something like this, x. Let's make it x cubed. This is a rational. I have a numerator and a denominator. My degree on top is bigger than my degree on bottom. So this is an improper rational that leads us down this path to doing long division or synthetic division to rewrite. So I don't know how long ago you took Algebra 2 and learned synthetic division, but this is a case where synthetic division applies. Remember, you can only do synthetic division if you have x minus c, so you can't have any coefficient on your x in order to do synthetic division. So I can do synthetic division here. I put a -1 in the box, and then I list my coefficients up top here. So my coefficient on x cubed is 1, x squared is 4. There is no x term, so I have to leave a 0, and then -9 on the end for my constant. We're going to pull, and then we're going to multiply and add. So I multiply what's in the box. I get -1. I add and get 3. I multiply what's in the box. I add and get -3. I multiply what's in the box. I add and get -6. So that was a really quick synthetic division review. I assigned it to you on Wednesday, so feel free to go do it in the Delta. So what we're doing here is we're going to rewrite this. We're going to rewrite this whole integrand. This is not the taking of the integral. This is just a rewriting. So if you remember from your Algebra 2 days, this is a remainder. This is your constant. This is your x. This is your x squared term. So we can rewrite this integrand as 1x squared plus 3x's minus a constant of 3. And then, we're not in 4th grade anymore where we say remainder -6. We're going to have minus 6 over x plus 1. And that is the new integrand for us to integrate. Hooray, it's much easier. So here we go. These are just power rules, these first 3 terms. Whoops, taking the integral. So I'm going to add 1, divide by the new, plus add 1, divide by the new, plus add 1, divide by the new. So all 3 of these are just power rules. What about this thing? So I'm going to pull this down separately just for this first one. Hopefully we never have to do this again, but I want to talk about it. Can I ignore the fact that it's negative for a second and just make it a 6? This is what we're looking at. So I'm even pulling the 6 out because that's also not that important to me. This is a u sub. I would make u equal x plus 1 so that du then equals just dx. And I could rewrite this as 6 times the integral of 1 over u du. But I don't have to do this. I mean, I guess I should finish before I tell you what you don't have to do. There's a 6. This is now natural log, always absolute value of u, so x plus 1 is what u is. I don't have to do this with a u sub. Remember, the purpose of a u sub is to undo a chain rule. There's no chain rule. The fact that I got du and dx are equivalent means that there's no chain rule here to worry about undoing. So if I have something like I have a linear factor in the denominator, it's just going to be a natural log. If you don't believe it, think about what this derivative would be. I'd have a 6, and then it's 1 over whatever's inside there. So it's 1 over x plus 1. It's that fast. So don't forget the fact that it's negative. There's a 6, natural log, absolute value, x plus 1 plus c. All right, let's do another one. So let's integrate 8x cubed, 14x squared minus 22x minus 11 over 4x plus 3. All right, it is rational, polynomial. It is improper. Degree on top is bigger than degree on bottom. So following the flowchart says I need to do division. Unfortunately, synthetic division does not apply because I have a coefficient on x. So I'm going to have to use long division. Remember, long division is the one that always works. So if you don't ever want to use synthetic division, you don't have to, but it is like significantly faster. So here we go. Long division. How many times does 4x divide into 8x to the third? That would be 2x squared times. Notice how I'm lining up terms where they go. So I'm putting the x squareds on top of the x squareds. Now, just like in numeric long division, we're going to multiply everything. So I get an 8x cubed and I get a 6x squared, positive and positive. Then we change the signs and add. These have to go away or you did something wrong. Now I have 8x squared. And I pull the next one down. Rinse and repeat. How many times does 4x go into 8x squared? That would be a 2x number of times. Multiply it out, and I get 8x squared and 6x. Change the signs and add. These are gone like they have to be. This is going to be a negative 28x. Pull the next term. How many times does 4x go into negative 28x? That's a negative 7. Multiply. This is now a negative 28x and a negative 21. But I'm going to change the signs and add. So my remainder here is a positive 10. So exactly like we did above, we're rewriting. So my answer, my quotient, is 2x squared plus 2x minus 7. What was my remainder? 10. So plus 10 over 4x plus 3. And that's what I'm going to integrate instead. Much simpler once I get it set up. So here I go. These are all power rules again. I'm going to add 1, divide by the new. I'm going to add 1, divide by the new, add 1, divide by the new. This is again, and it will always be, well, that's not true. It will almost always be a natural log of some sort. If you need to do it with a u sub, do it with a u sub. That's fine. I think I will show it to you just because this is a video, and so I'm supposed to be teaching you, I guess. I'm going to pull the 10 because I'm always going to pull a constant if I can. If I choose to do this with a u sub, I have to think of u as 4x plus 3. This time du is 4 dx, and I have a 4 to undo. I'm undoing the chain rule. So when I go write this in terms of u, I'm going to have 10 fourths on the outside. Yes, I know it reduces. And then du over u, there's my natural log that I was looking for. So I won't finish that. But this is going to be a positive 10 over 4 is 5 over 2. Natural log, absolute value for x plus 3, and then plus c on the end. and that is taking integrals when you have to do division first. All right, on Monday, when I see all of you together in person for your computer in person, I get to see your face, we're doing that one. It's going to be fun. Let me know if you need anything.